When we first scrape or collect information, it usually arrives as an unorganized sequence of text characters, known as strings, or simply a chaotic stream of raw numbers. On its own, this raw data is useless for analytics. If a computer cannot logically group, sequence, or contain these loose data points, we can't ask questions about it or extract any meaningful patterns. That means the very first step in any data analytics pipeline is containment. We have to force that chaos into a mathematical structure. The default tool for containing data in Python is the list. Its defining characteristic is right in the name. It takes raw information and places it into a defined, sequential order. Lists are created using square brackets. They are flexible containers that can hold entirely different data types right next to each other, like text strings alongside integers, and they permit duplicate values to exist within the same sequence. Here is a list. Test scores 85, 92, 78, 92, and 65, inside square brackets. Python tracks this sequence using zero-based indexing, starting from 0. Being mutable, we can overwrite the 78 at index 2 with 80 and append 95 to the end. Lists are versatile for processing general sequences, but that exact mutability introduces a specific risk. If we are handling permanent data that should never be altered, a list leaves that information exposed to accidental overwrites. Imagine storing sensitive information, like a set of exact geographic coordinates or a permanent user ID inside a standard list. One stray line of code could accidentally mutate that data, corrupting an entire analysis without triggering an error. Python solves this by using a structure called a tuple. A tuple is an ordered sequence of data, just like a list, but it is strictly immutable. This diagram shows how the syntax physically changes. When we replace a list's square brackets with parentheses, the data is mathematically locked in place. No new items can be added, and existing items cannot be altered. By enforcing this strict immutability, tuples upgrade data points from flexible sequences into fixed, incorruptible records within your pipeline. Sometimes the order of our data is irrelevant. Instead, the challenge is ensuring there are 0 duplicate entries in our dataset. For this, we use sets. Denoted by curly braces, sets are unordered collections that automatically identify and remove duplicate data the moment they are created. This diagram illustrates how sets handle overlapping information. Let's look at 2 distinct groups of customer IDs, a set of loyal customers on the left and a set of new customers on the right. Staying with this visual, watch how sets allow us to run instant mathematical operations. Without writing complex logic loops, we can instantly find the intersection of both groups, customer 105, or isolate the IDs that are exclusive to the loyal group. By using a set, a developer replaces hundreds of lines of comparison logic with a single native operation that allows for the immediate filtering and comparison of massive datasets. There is one final structural problem to solve. Lists and sets contain values, but they lack context. If you have a stray number 1200 sitting in a list, it's difficult to interpret what that number actually represents. We solve for context using dictionaries. Dictionaries utilize key value pairs to map descriptive text labels directly to specific data points. This diagram represents a product information dictionary. Inside the curly braces, we assign specific keys to values. The key name maps to laptop, the key price maps to 1200, and in stock maps to the Boolean value true. Looking closely at this structure, there is a specific rule. Dictionary keys must be unique and immutable. This means an analyst can query the price key and instantly retrieve the associated value of 1200. Even with strict keys, dictionaries themselves remain mutable. We can inject a new key value pair into the existing layout to record that the product's brand is TechCo. Dictionaries elevate isolated data points into fully structured human-readable records. In fact, this key value mapping is the standard format used by modern web systems to pass information back and forth. By choosing between a list, a tuple, a set, and a dictionary, an analyst exercises total control over the rules of order, mutability, mapping, and uniqueness for any given dataset. These 4 containers are the internal architecture of the Python language, managing how data is stored and retrieved at the most basic level. This diagram shows how industry-standard tools like pandas rely on these foundations. In a complex data table, a vertical column behaves like a highly optimized list, while a horizontal row operates as a dictionary. Mastering these distinct tools is the definitive step towards turning raw, fragmented information into a structured environment that is ready for analysis.